Yellowstone National Park is world famous for its wildlife, its beautiful canyons and geysers, and its super volcano. But how did it all begin? Let's find out in today's episode of National Park Diaries. It's me, and if you want to join me on my adventures through America's national parks and historic sites, hit that subscribe button. The story of Yellowstone actually begins before there was a Yellowstone. It starts with a massive meteor strike in what is now Arizona that created an impact crater so large it was literally the size of Manhattan. This event happened about 50 million years ago and is better known as the Chicxulub meteor event, which you may recognize as the same meteor that killed off the dinosaurs. But while the meteor killed off most life on Earth, some small mammals survived, including the ancestors of modern bats. These little guys were just minding their own business, surviving on insects and fruit, when suddenly the earth began to rumble. You see, somewhere in the northwest corner of what is today the United States, there was another giant volcano like the one at the center of Yellowstone today. And this one wasn't feeling too friendly. It had been brewing for hundreds of thousands of years, and finally it blew. This was no ordinary volcanic eruption. It was the largest in the history of the Earth. The magma chamber beneath the volcano was gigantic, stretching almost 50 miles from north to south and nearly 30 miles from east to west. When it exploded, the blast obliterated everything within 600 miles, including the little mammal friends we were hanging out with earlier. In fact, the only thing more powerful than the explosion itself was the massive pyroclastic flow that followed. Pyroclastic flows are hot, fast-moving mixtures of gas and rock that rush down the side of a volcano during an eruption. And this one reached speeds of up to 70 miles per hour, which is fast enough to level a small city in less than a minute. After the dust settled, there was nothing left but a massive new caldera, roughly the size of the current Yellowstone Caldera, filled with glowing hot magma. The surrounding area was completely barren. All the plants and animals were gone. But life is resilient, and over the next several million years, the land would slowly come back to life. In the meantime, the magma beneath the surface cooled and hardened, creating a massive new igneous rock called the Yellowstone Igneous Province. As the region slowly recovered, this igneous rock became the foundation of the Rocky Mountains. Meanwhile, the Chicxulub crater continued to fill with water and eventually became a vast tropical lake. So far, this is pretty similar to what happened at Yellowstone. But now, things get kind of weird. As the Rocky Mountains continued to rise, they pulled the eastern side of the North American plate towards the west. This caused the western side of the continent to buckle and fold, creating a massive trench in the process. This trench ran roughly along the coast of what is now California and stretched all the way up into British Columbia. Now, because the western edge of the continent was being dragged down, I also pulled the eastern edge down with it, and the piece of land that got stuck in the middle formed what we now call the Basin and Range Province. Much of today's western United States is part of this province, and it is characterized by long, narrow valleys that stretch for hundreds of miles, separated by large uplifted blocks of land called horsts. These horsts can reach elevations of nearly 9,000 feet, and they form the core of many mountain ranges. But even though they're so tall, they still seem oddly out of place. That's because they're not supposed to be there. You see, these horsts are actually a result of normal faults, where the land on either side of the fault line moves downward and away from each other. Basically, the Rockies are pushing so hard on the North American plate that the land is splitting apart. And although it may not seem like much, this has been happening for millions of years. In fact, parts of the Basin and Range Province have been moving away from each other at rates of nearly 2 inches per year. To put that in perspective, San Francisco only moves about 1 inch closer to Los Angeles every year. Yellowstone sits right in the middle of this province, and the park's entire geology is a result of this phenomenon. It all started about 17 million years ago when magma began to well up from deep within the earth. This magma didn't come from the Yellowstone hotspot like the current magma chamber does, but rather from the subducting 1D Fuca microplate. You see, the North American plate isn't the only thing moving. The Pacific plate is moving toward it as well. And where the two meet, the ocean water on the bottom of the Pacific plate gets dragged down into the planet, or at least it will eventually. Right now, it's getting stuck, and that's creating pressure and heat. And where you have heat, you have magma. And where you have magma, you have volcanoes. For a couple million years, this magma chamber fed volcanoes both above and below the surface, creating large volumes of rhyolite and trachyte. Rhyolite is an expensive igneous rock that typically forms from magma that is rich in silica and aluminum. And trachyte is similar to rhyolite, except it's a bit more porous. Both rocks are light-colored and fine-grained, and together they formed large lava plateaus around the center of what is now Yellowstone. These plateaus are part of what geologists call the Yellowstone Flood Basalt Group, and they are estimated to be between 16 and 8 million years old. During the early Pleistocene epoch, something amazing happened. The magma chamber beneath the surface began to collapse, creating a massive caldera. But this wasn't like any other caldera. It was enormous. At 43 by 28 miles, it is among the largest in the world. But that wasn't the end of it. It happened again and again and again. Over the last 2 million years, the caldera has been the site of at least 3 super eruptions. Each one was more powerful than the last, hurling over 2,400 cubic miles of ash and pumice into the atmosphere. And after each one, the caldera filled with water to form what is now Yellowstone Lake. So when you visit Yellowstone today, you're exploring the remnants of all those past eruptions, the oldest of which date back nearly 2 million years. They blew themselves out in 3 massive pulses, sending layers of ash as far away as the Gulf of Mexico. That's a journey of over 1,000 miles. But none of those eruptions compared to the one that happened 640,000 years ago. This is by far the most violent period in the history of Yellowstone. A magma chamber nearly 30 miles wide began to form beneath the surface, and over time, it forced its way upward. Between 66 and 630,000 years ago, it violently erupted in what geologists call a caldera-forming eruption. They blew out 2,800 cubic miles of material in a series of discrete pulses. But the total volume of material ejected was equivalent to 1,000 of the 1980 Mount St. Helens eruption. To put that in perspective, Mount St. Helens was the deadliest eruption in U.S. history and the most violent since Krakatoa in 1883. And yet, it was 1,000 times less powerful than one day at Yellowstone. But even though Yellowstone is clearly super powerful, it has never been the super volcano it is today. For most of human history, it was just another pretty average volcano until just recently. See, about 13,000 years ago, the North American plate began to move west a little faster. This caused the Yellowstone hotspot to begin moving northward, which means that instead of the magma chamber feeding the Yellowstone caldera, the magma chamber migrated about 50 miles to the northwest, creating the magma chamber that feeds the current Yellowstone supervolcano. Today, the Yellowstone supervolcano is 43 by 28 miles across, making it one of the largest active volcanoes in the world. It contains a massive magma chamber filled with extremely fluid magma that is low in silica and high in iron and magnesium. In fact, it's so large that it's considered to be a mantle plume, a gigantic column of hot rock that stretches from the core of the Earth to the surface. And scientists think it's responsible for many of the geothermal features found throughout Yellowstone. This includes Old Faithful, one of the most famous geysers in the world. But there's more to see in Yellowstone than just geysers. There are also bison, wolves, bears, and elk. And to learn more about them, make sure to check out my guide to visiting Yellowstone. And if you want to see more from the park, make sure to check out my Yellowstone playlist. That's it for today, folks. I hope you enjoyed this episode of National Park Diaries. If you want to help support the channel, like this video, hit that subscribe button, and leave me a comment. I love reading your suggestions for future episodes. Thanks for watching. See you next time.